Welcome to This Explainer. Okay, today we are unpacking something absolutely mind-blowing. What if I told you that literally everything you see right now, the room you're in, the screen you're watching, the sky outside, exists because of something you can never, ever physically touch? It's the most ubiquitous, yet entirely mysterious force in our daily lives. Okay, let's dive into this. What exactly is light? Is it a kind of energy? Is it a wave, just rippling invisibly through the air? Is it a tiny particle? Or is it something much, much stranger? Today, we're going to explore all of this, taking a journey from the very basics of human understanding all the way to the wildest discoveries in modern physics. Section 1. The familiar world of light. So, think about this. Every single morning, sunlight reaches Earth and just completely lights up our world. We switch on a light bulb, we stare at our glowing screens, we snap photos on our phones, we're completely bathed in it all the time. But how does that everyday light actually work? Well, this brilliantly illustrates exactly what's happening right above our heads every single day. See, sunlight actually contains every single color, but as it hits Earth's atmosphere, the shorter wavelengths, like blue light, scatter much, much more easily. This structured cause and effect is known as Rayleigh scattering, and it's exactly why the sky looks blue. But then, at sunset, that same sunlight has to punch through a much thicker slice of the atmosphere. By the time it reaches us, almost all that blue light has been scattered away, leaving only the longer red and orange wavelengths to reach our eyes. Now, what about the solid stuff right in front of you? Pure white light, as we just mentioned, is packed with all the visible colors, from deep red to vibrant violet. But everyday objects don't actually make their own color. Take a yellow banana, for example. It doesn't glow yellow. It looks yellow simply because its surface absorbs almost all the colors from the light hitting it, and it only reflects those specific yellow wavelengths right back into your eyes. Let's move to Section 2 and see how this builds into something wilder. Peeling back the reality of light. As we step away from the familiar colors of our homes and get into the invisible, far stranger physics of what light actually is, we find that at its absolute core, light is a form of electromagnetic radiation. It is pure energy, traveling through space as oscillating electric and magnetic fields. Now, here's a massive difference between light and something like sound. Sound desperately needs a medium, like air or water, to travel through. Light? It doesn't need anything at all. It moves completely effortlessly through the dead vacuum of space. And that is exactly how sunlight manages to travel nearly 150 million kilometers through absolute nothingness to keep us warm. And it makes this epic journey in the form of something called a photon. Now, a photon is an elementary particle, but it totally breaks the rules of what we normally think of as physical matter. It has absolutely no rest mass, none. It carries no electric charge. It always moves at the speed of light, and each one carries just a tiny, discrete packet of energy. Right now, literally as you're watching this explainer, billions of these bizarre, massless particles are slamming into your retinas every single second, just to create the reality you're seeing. So the crucial point is, we've got one of the biggest mysteries in the history of physics on our hands. Decades of hardcore experiments show us that light behaves exactly like a wave. But then, other experiments completely prove that it behaves like tiny little bullets, those particles, the photons we just talked about. This mind-bending paradox is known as wave-particle duality. Depending entirely on how you observe it, light can act as both. It completely defies everyday logic, but it's a fundamental property that's explained beautifully by quantum mechanics. Moving right along to Section 3, Cosmic Speed and Scale. To really, truly wrap our heads around light, we have to zoom way out to the macro level and look at its sheer, unimaginable speed. 299,792,458 meters per second. That is the exact unyielding speed of light in a true vacuum. We are talking roughly 300,000 kilometers every single second. At that blazing speed, a beam of light could whip all the way around the Earth more than 7 times in 1 second. And yet, space is so unfathomably vast that even at this absolute maximum speed limit of the universe, it still takes time for light to get anywhere. Light reflecting off the moon takes about 1.3 seconds to reach us. Light from the sun? Around 8 minutes and 20 seconds. Just let that sink in for a second. If the sun were to just suddenly vanish, like completely disappear from existence, we wouldn't even know about it for 8 minutes and 20 seconds. We'd just be walking around, totally clueless, bathed in the very last of its light. And the nearest star after our sun? It takes over 4 years for its light to finally reach our telescopes. Now, actually, scratch that. There is one fascinating exception to this cosmic speed limit. While light absolutely redlines at its maximum speed in a pure vacuum, it can actually be slowed down. When light tries to pass through denser stuff like water or glass or a diamond, the photons have to interact with all the tightly packed atoms inside. That interaction causes the light to actually slow down and bend. That's exactly why a straight straw looks sort of broken or shifted when you drop it in a glass of water. And it's the exact same physics that makes things like eyeglasses and camera lenses possible. Now, what's really interesting about this is just how completely blind we humans actually are. Visible light, the rainbow of colors we can see, is just a microscopic sliver of the full electromagnetic spectrum. This whole spectrum includes radio waves, microwaves, infrared, ultraviolet, X-rays, and even gamma rays. The only difference between a radio wave and the color red is just their wavelength and frequency. We are constantly swimming in this massive, invisible ocean of light, but our eyes are only equipped to detect a tiny fraction of it. Meanwhile, tons of animals out there can see wavelengths that are completely invisible to us. Section 4. Einstein and extreme physics. You really can't tell the story of light without talking about Albert Einstein. Back in 1905, he practically reinvented reality by successfully explaining the photoelectric effect, using that concept of photons we discussed earlier. A massive breakthrough that ended up winning him the Nobel Prize. But Einstein went even further. He proved that the speed of light is completely constant for every single observer, no matter how fast they themselves are flying through space. This mind-bending concept became the bedrock of special relativity, and it laid down a harsh, unbreakable law for the entire cosmos. Absolutely nothing with mass can ever travel faster than light. But what about the path light takes? Think about it. If light has zero mass and it travels in a straight line, can it actually be bent? Well, the answer is yes. Einstein's theory of general relativity tells us that incredibly massive things, like entire galaxies, actually warp the very fabric of space-time itself. So light, just cruising through space, has no choice but to follow these massive invisible curves. This wild phenomenon is called gravitational lensing. It basically acts like a giant cosmic magnifying glass, letting astronomers see galaxies that are billions of light years away, hiding directly behind other massive objects. And finally, Section 5, light across the cosmos. So, how does all this weird physics actually build our modern world? Well, closer to home, modern civilization entirely depends on our mastery of these bizarre quantum properties. Without understanding how light works, our current tech would barely even exist. We're talking fiber optic internet blasting data across oceans, insanely precise laser surgeries saving lives, barcode scanners, satellite communications, solar panels, medical imaging, all the way up to the bleeding edge of quantum computers. The whole shebang is powered by manipulating photons. But light isn't just a fancy tool for us to use. It's quite literally the ultimate time machine, 13.8 billion years. Scientists have actually detected the absolute oldest light in the entire universe, this ancient, faint glow known as the cosmic microwave background. This light was released a mere 380,000 years after the Big Bang itself. It's been traveling continuously through the cold void of space for over 13.8 billion years. When we detect it today, it gives us an actual physical snapshot of the baby universe. And that brings us full circle to this profound realization. Every single star you look up and see in the night sky, you're actually viewing it in the past. Light perfectly connects the absolute smallest elementary particles to the absolute largest, most ancient galaxies. Every single ray of light hitting your eyes right now is carrying a story that started somewhere deep in the cosmos. We hope you've enjoyed exploring the deeply fascinating, luminous architecture of our universe through this explainer. And I'll leave you with this. If the light we see today is merely a ghost of the past, what undiscovered ancient stories are currently traveling through the dark, just waiting for us to open our eyes and see them?